Now let's take a look at question 13. Move this lower, like that. Alright, so if the series f(x) equals 2x minus x squared plus 1 divided by 3 times x cubed, then the next one's going to be minus, and then the next one's plus, etc., converges for all x, then the third derivative at 0 equals to 2. Alright, so let's take a look at the solution, and this is in fact true. And there's two ways of solving this. Let's look at solution 1. This involves the coefficients of a power series. So this is a power series, coefficients of it. Recall the formula for the coefficients of a power series. So this is if f has a power series representation or expansion at a, that is if f(x) equals to summation from n equals 0 to infinity of cn times x minus a to the power of n. And the absolute value of x minus a is less than r, that's the radius of convergence. Then its coefficients are given by the formula Cn. So these coefficients equals to the nth derivative of f at a divided by n factorial. Thus, in our case, we only need to consider the third coefficient because we want to get where this is n equals to 3. Yeah, so this is going n equals 0, so the n equals 3 coefficient. I'll just put this like this. N equals 3. Coefficient, just because there's a 0 there, so that would technically be the fourth. So we just need to look at the n equals 3 coefficient there. So, yes, so let's just write this one out as this. So what we have is here. So we know that the coefficient Cn equals to f, the nth derivative at a divided by n factorial, and where f of x is equal to the summation, so as a power series form here, this equals to the summation up to infinity of n equals to 0, and then we have Cn x minus a to the power of n, and now this equals to, well, this a is equal to 0 in our case. So a equals 0 in our case, because you can see this x, there's no 0, there's no a there. So it's just x at the end. So then this is going to be 0. So in our case, it's going to be, well, we have 2 to the x, like that. And in this case, you can see there's a 0 there. For n equals 0, it just vanishes. So this would be power of 1. So this right here is our c1 equals to 2. And then the next term is negative x squared. Negative x squared. So this is going to be, well, c2 equals negative 1. And the next one's going to be plus. Now we have a 1 over 3 x cubed. X cubed, and then it goes minus plus dot dot dot. So we only need to worry about this one. That's going to be our c3 equals to 1 over 3. Alright, so what this means is, well, we could just take this this coefficient right there as 1 over 3 and throw that into this formula for n equals 3, and we can get the third derivative, or f triple prime, and then rearrange it to solve for what it is. So what we have is, well, c3, this equals to, well, f of the third derivative, just write it like this for completeness, a is 0, and then this is going to be 3 factorial. This equals to, it's the same thing as writing f triple prime, like that. Yeah, it's the same way as writing that derivative there, divided by 3 factorial. Now this equals to, well, we're given it's equals to this. So 1 over 3. So what this means is we could move the 3 factorial over to the other side. So what we get is f triple prime at 0 equals to 1 over 3. So 3 factorial divided by 3. And 3 factorial is equals to 3 times 2 times 1 over 3. This cancels, this cancels. 2 times 1 is just 2. So this is true, and yes, we're given converges for all x, then f triple prime 0 equals to 2, and that is true. So that's solution 1. That's just using coefficients of a power series. We know it's a third one. And the other solution is we could just do it all directly. Yeah, so let's take a look at that. So solution 2, so we could just differentiate f. Yeah, so we could just differentiate it or take a derivative of f multiple times. So we can also just take the derivative 3 times and plug in x equals to 0. So let's look at our f of x. So that's f of x, and let's take the derivative 3 times. So we'll start with f of x equals 2. So fx equals 2, let's see that again, 2x minus x squared, and then plus 1 over 3x cubed. So this is going to be 2x minus x squared. Was that over 2, I think? Let's go over here. Yeah, no, there's no over 2. 2x minus x squared. And then the next one is over 3. Plus 1 over 3x cubed. Yeah, so we have 2x minus x squared plus 1 over 3x cubed, and then it goes minus plus, etc. Minus plus dot dot dot. Alright, so that is f of x, and let's take the first derivative. So f prime of x is equal to, well, derivative of each term. So 2x derivative is just 2. And then this one here, if you recall the power rule, just goes down. So this 2x goes down and you subtract the power. The next one here is plus, the 3 goes down, 3 over 3, and then x squared, and it goes minus plus dot dot dot. Alright, and then these ones cancel, that just becomes 1. So then take the derivative again. This equals 2, well the derivative of 2 is just 0. And then this next one is the negative 2. And then here's going to be plus, well 3 over 3 is just 1, so then bring this derivative of this x squared, the 2 goes down. We have an x like that. It goes minus plus dot dot dot. Alright, and then the third derivative, f triple prime of x is equal to, so this is 0, this one vanishes. Now here is a negative 2, goes to 0 as well. Plus, well, now we have a 2, derivative of 2x is just 2. And then it goes minus plus dot dot dot. And all these over here, let's put this here. Then this goes, all these terms here, all contain x. So that means, and then they go to 0. It goes to 0 as x equals to 0. So they all equal 0. Or better yet, when we plug in 0 there. So I just put that at there, not as. And then this one equals 0 at x equals 0. So plug that inside. So we get f triple prime at x equals 0 equals to, well, just 2. And everything else vanishes. And this is the same as what we were asked. So f triple prime of 0 is equal to 2. So the third derivative at 0.